Hey, Mr. H back with you. We are still dealing with some logarithms here. So we're going to jump in and we're going to learn a little bit about properties. We're going to be using these to solve some things. So normally when we do algebra, we got some rules involved. But the cool thing is going to be, hopefully this is going to connect with some rules that we've done somewhat recently, and we can kind of make a connection here. So be looking for the pattern. So here we go. So when we're going to expand a logarithm, we're going to stretch it out. We're going to make it bigger. The first one we're going to deal with is the product property. We're multiplying them together. So when we do this, here's what expanding this particular log would look like. So we'd have log x plus log y. So when we're expanding and there's multiplication, there's a product, the product will become addition. So multiply will become add. Okay? So keep thinking here. Start thinking multiply and add. I've heard that somewhere before. Okay, division. When we get to the division part, the divide will become subtract. Log x minus log y. So divide becomes subtract. Does that seem familiar? Multiply, we add. Divide, we subtract. Oh, exponent rules. Okay, same things apply here. Multiply becomes add. Divide becomes subtract. Now, the last one that we have here, this one's different. It has got its own little thing here. So, there's always got to be one exception, right? You're like power property. Are we going to multiply? No, even though good job on remembering the multiply property. When we've got these, it's going to do something a little strange. That exponent is going to swing to the front of your log and become a coefficient. Okay, so how would you write this down? That's weird. Okay, so here, exponent becomes coefficient. Okay, those are the three rules. So when you're working on these, one other thing I would suggest when you're expanding, and let me try to get them all back in here together, is that you try to do them when you have, because you will have multiple properties in a lot of these problems. I would try to do them in this order, okay? If there's any multiplying turning into an add, do that first. Dividing and subtract, do that second. Exponent to coefficient, you want to do last because it's going to cause less problems, okay? So let's play with a couple of these. That's usually the easiest way with anything to get rolling so we don't get too confused here. So fully expand the following logarithms. Okay, I notice there's multiply here, so I'm going to do that first. So I'll do it in the same colors here. So we're going to have log of 4. Whenever you see the multiply, that's going to become plus. And we're going to start a new log with that one. So we got to keep putting the log in with each one. You can't just write log 4 plus x3 plus y5. You literally are giving each one of them their own logarithm. Okay. There is no subtraction. I don't see division anywhere, so I don't have to do that one. And then my last step would be to do my exponents are going to turn back into coefficients. So there's no exponent really there on my 4 that would do anything. We just leave that alone. Plus 3 log x plus 5 log y. And the nice thing about doing them in order is once you know and you've gone through each of the possible steps, and then you get to the end, you're like, oh, I don't have any other steps I can do. I'm done. And it's not, am I done? Am I sure? And you can kind of work it out that way. So now, is there going to be weird with some of these? Of course, there's going to be weird with some of these. Wouldn't be not weird if I wasn't running it here. So what do I do here? Because there's multiply, there's divide, and there's an exponent. So do I stay in the same order? I'm already going to break my own rule. In this particular case, no. If these were all separate, like they were here, and one had, a times and another one had a divide, I'd do it. When there's an exponent out here, okay, we're going to go ahead, we're going to clean that up first. This is the one time we're not going to go with the exponent to coefficient at the later part. And we know how exponents work. This is going to every single thing inside the parentheses. So we're going to rewrite it first. So 3 squared is 9x squared over y squared. Okay, we're just going to rewrite it first. Now I'm going to follow the rules that I did before. Because now my exponents are only on individual terms, the x and the y here, and that's not to everything. So now if I go through and I follow my rules, okay, multiply would come first. So I'd have the natural log of 9 plus, because remember there's a little multiplication dot in there, even though we don't see it, the natural log of x squared. And here's one other thing I would do. We're going to think about the calculator on this. Since I want these together up here in the numerator of my fraction, I'm going to put parentheses around, just so somebody comes along, they're going to know what's going on here. Divide by the natural log of y squared. Okay, because I'm only going to do this one step at a time. If some of you want to try and do multiple steps, you can, but I would do it one piece at a time here. So I get to the next part and I say, okay, I see division, that's going to be subtract. So I leave this part alone. And then divide becomes subtract. Okay. Now, if some of you are comfortable, like I could have just done that all in the one step when I looked at it. That's fine. I mean, not a bad thing. But that's how you normally would deal with that. And then finally, if I have exponents, and I have exponents, those are going to go back into the front as coefficients. Now, okay, so here's the question that somebody's probably thinking if they didn't say it out loud already. What if I don't put the parentheses in? Is that wrong? Technically, it wouldn't be, because with order of operations, you'd work from left to right, okay? I just like keeping them grouped off like that, kind of as a note to myself, oh, this is the numerator, this is the denominator. But yeah, in a case like this, it would not make a difference. So like if this was delta math and you didn't have the parentheses, you'd still have the right answer. Okay, it's just something to keep in mind. Okay, so that's expansion. We go from a little log or a little natural log and really get it really big. Now, like we do so often in math, we're going to go the opposite direction. So what we're going to do is we are going to do what's called condense. Now, when you condense something, you maybe think of this with like your stuff at home. If you have too much stuff, you're going to condense how much stuff you have. We're going to smash it in. We're going to make it smaller. So remember your expand properties as we flip over, and you're like, oh, wait a minute. Hey, Hardy. So what you're telling me is we're just going to undo everything we just did. So if we're condensing, okay, we remember add and multiply go together. So when we condense, we're condensing to 1 log, and add turns into multiply. It's the exact opposite. It's the inverse of what we were doing before. And that's going to be true with all of our properties. Our quotient property, if I see minus and I'm asked to condense it, that subtract is going to turn into division with 1 log. We're smashing 2 logs or 3 logs or however many logs down to 1. So again, subtract becomes divide. And then comes our oddball here, okay? When we have a coefficient and we have the power property, that coefficient is going to go back to being an exponent of whatever that base is. So it's the exact same things as before, except we're flipping them. And here's the one other change, which you're probably not going to be surprised at with this. Last time we did product, quotient, power. 1, 2, 3. Well, since we're undoing them, we're condensing them, we're going to do it the opposite way. So any coefficients are going to become exponents first. And we're just going to work backwards. Okay, now again, do you have to necessarily? This can get to be quite the mess if you don't, especially if you don't do these first. So I'll probably talk about that here for a little bit as we're looking at them anyway. So, okay, fully condense. So we're going to take our own advice. Okay, if we have coefficients, and we do, those are going to become exponents first. So the natural log of a to the 4th plus the natural log of b to the 7th plus the natural log of c. Once we get that set, okay, if there would have been subtracting, we'd have done that next. There's no subtracting, I can't do that. So really there is no step 2. Okay, if there's adding, there is, that becomes multiply. Now remember, we're trying to get this down to a single logarithm, or a single natural log in this case. So you've got options here. If we're trying to get it all set at once, here's what I would do. So I'd have a to the 4th, add becomes times, b to the 7th, add becomes times, c, 1 log. If you wanted to go through and write natural log of a to the 4th times natural log of b to the 7th times, you can, but the whole thing here is that there's 1 log only with these answers, and that's whether it's a log or a natural log. Doesn't matter. Okay, and then the last one here, we get to do the whole gamut. And when you're doing your exponent, notice I'm not taking the negative with. Leave the signs alone. Just take the coefficient with these. So log 3 plus log x minus log w to the 5th, coefficient to exponent. We do have subtraction this time, okay? So here's where I've got to be a little bit more careful. So again, I look and I go, okay, there's my subtraction. So, let's see, we're going to experiment here. Because remember, whenever we condense anything, we're smashing it down into 1. So we have these 2 logs that we were subtracting and condensed it down into 1 fraction. And now we're going to take this last piece and we're going to look. Now, let's see if something different happens and how this would change or what we're going to do. This is what you get when you get me live here. So if I did this here, I would have log 3 times x over w to the 5th. Now, what if I'd have done these in a different order? What if I'd have done, you're like, Hardy, we hate it when you do this, but I want you to be able to think outside the box here. What if I'd have just gone left to right when I got to this step? Okay, what if I'd have done that? So I'd have had log 3 times x, and then I turned it into log 3x over w to the 5th. Now, those are actually the same thing, okay? Because if I take 3 times something, I can put 3 over 1, multiply across, I get the same thing. This is a little bit neater, okay, as far as writing it that way. So, am I telling you that these 2 steps, step 2 and 3, are kind of interchangeable? It depends on the problem, okay? Most of the time going this way is going to be our easier route. But to be honest with you, we should be able to get there either way. But if you do one and it doesn't look right, maybe try the other and see if you end up with something that's a little bit different than that. So now, one last thing to play with here. And again, I'm hoping with the new year here, we're going to ask some more questions when we get stuck on things. So logarithms with bases other than 10 or e can be written in terms of common or natural logs using the change of base. Now, we've talked about change of base before, okay? So we can have a quick change base here. Now, I'll talk about the note at the bottom here in a second. So we can take log of what's called our of value. I call it the big number because that's big, that's little. Log big divided by log little. Maybe I'll grab my calculator. There it is. All right. So we got log, again, log right next to the 7 button there. Log 10, close your parentheses. Divided by log 2. So like 3.32. Okay. And then here, same thing. Log big divided by log little. And again, we're talking about the size of the numbers, not that 4 is bigger than 8. I'm a math teacher. I do know this. So log 4 divided by log 8. Oh my gosh. Log 4 divided by 8. Now, okay, I'm going to be straight up honest with you here. Note, if you have access to the TI-84, these problems can be done using the change of base feature under the math menu. Okay, let's be honest. Is it really hard to remember big divided by little rather than have one more thing on here? Now, half the SAT is no calculator. They're not going to ask you this on a no calculator. But if they did ask you something simpler, okay, they could ask you something simple like log 3, 9. You know, 3 to what power is 9? And you need to know it's 2 without having a calculator. But again, just remember big over little. We don't need more programs. Okay, enough of the Hardy lecture on that. So your job is going to be, once I locate it here, it's the one thing about the home office that Hardy could do without. There it is. That's what I was looking for. No, it isn't. There's a worksheet for this. You're like, yep, Hardy, you're right back in mode here. Oh, I am. The worksheet is very similar to what we had, even though it's like disappeared on me now. I had it in front of me before I started this, but it has now disappeared. Work on the worksheet. If you start running into trouble with it, I will be, aha. I knew if I stuck with it, I would find it. There it is. So again, condense, we're smashing. There's 2 natural logs here. I'm smashing it to 1 or something like that. And then on the next page, we've got expanding, okay, which again goes from little to big. And I'm sure we'll be talking about this during the meets as well as we're doing this, but kind of spread it out a little bit. Like I always say, try the evens or try the odds first, check them, and then go back from there. So nice to have you back, and we'll be checking in again soon.